Imagine a universe where particles can be in two places at once, where observing something changes its very reality, and where the rules that define everyday life simply fall apart at the tiniest scales. That isn't science fiction. It's the strange and fascinating world of quantum mechanics. In the ordinary world, our world, the rules are consistent and predictable. A ball tossed into the air follows a precise path defined by gravity, its speed and its angle. The universe at our size seems to play fair, letting us measure, predict, even control what's about to happen, but shrink down, way down, to the size of an atom. And suddenly, the playbook changes. Let's start with a single bright line. To see the world in a grain of sand, William Blake writes of glimpsing infinity in the smallest of things. Quantum mechanics suggests it's not poetic exaggeration, it's real. The universe, at its most minuscule, holds surprises we have only begun to comprehend. First, consider the idea of the quantum. Unlike the smooth, continuous experiences of our everyday lives, quantum physics says certain properties, like energy, come in tiny, indivisible chunks. Think of the way light appears to pour steadily from a lamp. Quantum thinking rewrites that. It's more like a shower of individual photons, each with its own packet of energy. The universe is pixelated, discrete pieces, not a fluid whole. Now, here's where things get weirder. When you toss a coin, it's either heads or tails, even if you don't know which until you look. But in the quantum world, before you check, it can be in a blend, a superposition of heads and tails. Until a measurement is made, the particle exists in a blur of possibilities, a smeared-out wave of maybes. The act of looking doesn't just reveal the answer, it causes the answer to exist. Let's sit with that for a moment. Something as simple as measuring or observing is what calls a possibility into reality. The universe only settles on an answer when someone checks the score. Without observation, reality remains clouded in probability. This isn't just about abstract theory. It's been demonstrated over and over in the famous double-slit experiment. Picture a screen with two slits, and you're firing particles, maybe electrons, at it one by one. You'd expect the electrons to go through one slit or the other, like throwing marbles. But the results are bewildering. Even if you send particles one at a time, the pattern on the screen looks like a series of waves interfering with each other. Bright patches and dark gaps, precisely as though each particle went through both slits simultaneously and interfered with itself. But if you try to detect which slit the particle actually passes through, the interference pattern vanishes. Now, the electrons behave like tiny marbles again, choosing one slit or the other. The mere act of watching collapses the wave into a single outcome. Reality, at its core, seems to care whether we observe it. What does that mean for causality, choice, or even existence? Are things only real when we measure them? Numerous thinkers have puzzled over this question, and not just in physics. Let's reflect for a moment on these words. We are what we repeatedly do. Excellence, then, is not an act, but a habit. These words touch on the power of process over static outcomes, of constant possibility rather than a single fixed state. In quantum mechanics, particles don't just move from point A to point B in a predictable arc. Instead, they explore all possible paths, every route, every potential future, all simultaneously, until an observation chooses the outcome. This leads us to perhaps the most haunting aspect of the quantum world: entanglement. Imagine two particles interacting, then moving far apart, even to opposite ends of the universe. Quantum physics tells us their properties remain linked. Measure 1. and you immediately know the outcome of the other, no matter how far away it is. Instantaneous connection, like two dancers moving in perfect sync, even when separated by light years. Einstein famously called it spooky action at a distance, a profound uncertainty about how information or even influence might be moving through the cosmos. Let's pause with a thought from poetry. Though lovers be lost, love shall not, and death shall have no dominion. Even when separated by unimaginable distances, entangled quantum systems remain deeply connected. It's a kind of immortality, an echo of a relationship that endures beyond separation. But quantum mechanics is not just about weirdness for its own sake. It is incredibly precise, underpinning the technologies that shape our world today. Lasers, transistors, magnetic resonance imaging, and even the smartphone in your pocket, they rely on quantum principles. The unpredictable zigzag of electrons powers every bit of computing we do. Think about this. The entire universe is governed, at its root, by mathematical probabilities. Where classical mechanics gives us absolute certainty, every effect a traceable cause, quantum mechanics trades certainty for chance. In a sense, at every moment, the universe is rolling the dice on what's possible. Here's another echo of quantum thinking from literature. All the world's a stage, and all the men and women merely players. On the quantum stage, particles, atoms, even light, are not fixed actors following a rigid script. Instead, they are improvisational, each movement shaped by probabilities, each interaction creating a new unfolding story. Another key feature, the uncertainty principle. It's impossible to know both the exact position and the exact momentum of a particle at the same time. The more precisely you measure one, the less precisely you can know the other. If you try to pinpoint where an electron is, its speed becomes more uncertain, and vice versa. Nature has built-in limits to what we can know, a fundamental fuzziness woven into reality. This principle has philosophical echoes, too. Sometimes the act of focusing sharply on one aspect of life means other parts become more obscure. Just as knowing precisely what the universe is doing in one way forces other possibilities into shadow. Reflect for a moment. The mind is its own place, and in itself can make a heaven of hell, a hell of heaven. The quantum world, too, allows for many realities. Potential heavens, potential hells. Our measurement, our observation, our consciousness helps choose which becomes real. That brings up one last profound question. What role does the observer play? At the most basic level, reality itself seems participatory. The outcome is not fully determined until something or someone interacts. In some interpretations, consciousness is central. In others, the act of measurement could be as simple as a photon colliding with a molecule. The debate continues. Does the universe notice itself? Or do we act as the eyes of the cosmos, resolving uncertainty into actual events? Let's return briefly to poetry. I dwell in possibility. This is the very heart of the quantum world. A universe brimming with potential outcomes, every moment a fork in an endless path. The everyday certainty we're used to is just an illusion, a smooth surface floating atop a sea of probabilities. So, to recap. 1. Energy, light, and matter are not continuous, but come in tiny, indivisible units called quanta. 2. Particles can exist in superpositions, multiple conflicting states, until observed. 3. The act of observation isn't passive. It calls possibilities into reality, collapsing the blur of maybes into a single outcome. 4. Experiments like the double-slit show particles acting both like waves and particles, depending on whether we watch. 5. Entanglement links particles across distance, binding their fates in ways that seem to defy space and time. 6. The quantum world operates on probabilistic laws, not certainties. At every moment, our universe explores a rich range of possible futures. 7. The uncertainty principle puts fundamental limits on what can be known and measured. 8. The observer, whether human or part of the environment, plays an essential role in forging reality from possibility. In the end, quantum mechanics invites us to rethink the most basic assumptions we hold about nature, what it means for something to exist, how the world changes, and even our role in that mysterious dance. It is unsettling, exhilarating, and deeply humbling. So, the next time you flip a switch, look at a laser, or make a call on your phone, remember, you're harnessing the peculiar power of a world built from uncertainty and possibility. A universe that, at its most fundamental level, is always a little unfinished, awaiting a roll of the cosmic dice, a flicker of observation, to decide what happens next. And as you ponder your place in this quantum world, consider that just as particles dance between possibility and reality, so too do our choices, our discoveries, and our understanding. The world is stranger, richer, and more interconnected than you can possibly imagine. So, is the universe weird? Absolutely. But it's our universe. One grain of sand, infinite possibilities, and endless wonder.